All right. Welcome to Doc Waller's Earth and Space Report for Friday, October 28th, 2022. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a leaf-strewn autumn evening in my hometown of Rockport, Massachusetts. These Earth and Space Reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life-sustaining environment, and who wonder about the greater cosmos, including our place in space and moment in time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on the 1623 Studios Community Access Cable Television channel. I am grateful for the continuing interest and support shown by Rockport educators and students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, sundry Earth and space scientists and communicators, far-flung friends, family, and other curious folk. Thank you for participating. This evening, I will be discussing the earthly challenge of discriminating between a meteorite or slag. I'll repeat that, meteorite or slag. The case of the Mysterious Allia Rock. This case study entailed vital contributions from students in two classes that I taught at Rockport High School. To them, I give my deepest thanks. So without any further introductions, I will let in a few more people on the waiting room and then share my screen, get to the program. Okay, so here we go. Admit all. Okay. And now, what is this? Okay. Share my screen. Okay. Oh, beginning. Okay. All right. So the title is Meteorite or Slag, the case of the Mysterious Allia Rock. And what Allia means will come clear pretty soon. And so let me also, there we go. Here we go. Okay. So I want to start first with some terminology. Sometimes it can be confusing what the different terms are. Let's begin with a meteoroid. That is basically a space rock coming from an asteroid, planet, or the moon. So we have meteorites that have hit Earth where we know they're from certain asteroids. Also Mars, the surface of Mars, and also the surface of the moon. So what qualifies a meteoroid to be something other than just a space rock? It probably has to be near Earth enough to be a potential meteor and meteorite. So what is a meteor? That would be a meteoroid that passes through Earth's atmosphere, heating to incandescence and glowing. Excuse me. So those are the streaks that we would call shooting stars. If they're really, really bright, we'd call them fireballs. And if they explode, they're called bolides. And so the Chelyabinsk event that occurred, I think in 2015, was probably a bolide. That was an exploding meteor. So what's left is a meteorite. That is a meteoroid that has survived passage through the atmosphere and impact with Earth. And so that's what you can pick up with your hands. They include three basic types: iron, and stony types. So you're probably all familiar with iron meteorites. Perhaps the largest intact one is this giant Willamette meteorite, which I believe is at the Museum of Natural History in New York, American Museum of Natural History in New York. There is smaller ones. This is a desktop type of meteorite. It's again an iron meteorite. And what is characteristic about these sorts of meteorites is they have these thumbprint indents, and there's a name for them. It'll be later on in the presentation. I don't remember the name. It's a crazy name, but that is indicative of an iron meteorite. These tend to be made out of iron and nickel and tend to be very magnetic. Okay. Hello. If you cut an iron meteorite open and then etched it with nitric acid after polishing it first, you might see this wonderful pattern of crystallization involving the iron and nickel. And it's known as a Widmanstätten pattern. And I think it's really cool. Oops, let's go back. And it can be seen, on all faces of an iron meteorite once cut, polished, and etched. Stony iron meteorites also have iron, but they also have these kind of inclusions of olivine crystals. And it's interesting, you would not know anything about these crystals looking at the surface of the meteorite, which looks a little bit rusty because of the iron. But when backlit, sliced thin enough and backlit, you can see these beautiful olivine crystals, which would otherwise be known as peridot. They're very gorgeous and very fragile meteorites. Then there are the stony meteorites, which have not very much iron in them at all. And the ones over here on the left are known as chondrites because of these spherical chondrules, which are basically what compose these meteorites. Once sliced, you'll see them. And there are a few millimeters in size, these chondrules, and they're actually thought to be the basic building blocks of what made the inner solar system. It was first chondrules after the nebula started settling down, the pre-solar nebula. And even more interesting, there are a type of chondrites that are known as carbonaceous chondrites, and they are full of tar-like substances which have been found to contain amino acids, among other things, and a lot of aromatics. If you heat one of these things up, you would smell the aromatics. I have yet to do that. I'm looking forward to it, doing that someday. So that's a chondrite. What's not a chondrite is an achondrite, and that's kind of an assemblage of hunks of stuff, stony stuff, and typically silicates, I believe, similar to what you'd find on the moon. So I'm going to give you a few seconds to try your hand at classifying these meteorites. These are all regarded as being meteorites. So you could start here. What do you think that is? It's got rust. What do you think this one is? Definitely you should be able to figure that one out. And then these higgledy-piggledy rocks are shown here. Those might be achondrites. And then I guess this could be a chondrite. What's your opinion? Many meteorites have this fusion crust from passing through the Earth's atmosphere, and which looks very different from what's on the inside. Here's the sort of meteorite collection that you might be able to purchase for not too much money. Obviously, this has a metallic luster, as does this. So you might classify those as metallic, but I don't know anything about these other ones. Astronomers have been able to figure out or create a model, a theory for the origins of these various kinds of meteorites. Beginning with the chondrites, They could come from a rubble pile, an asteroid, or part of an asteroid, which was regarded as a rubble pile, like the one that spacecraft DART just slammed into. And they can also come from larger asteroids, as from the outer parts of a larger asteroid. The iron meteorites will come from the core of a larger asteroid, because it had been able to differentiate. Basically, it was big enough to get hot enough to melt, and once melted, the heavies settled to the center, and then the lights floated towards the surface. And so there you can get the iron meteorites from the core, the stony iron meteorites from a transitional region, like a mantle, an inner mantle, and then finally the achondritic meteorites from the outer part of the asteroid, sorry. So here on Earth, we get rocks. Earth's surface is riddled with rocks. How can you tell whether you have found something that might be a meteorite? Usually, people notice that it's darker, but that's not enough. You need to go through kind of like a flow chart, which has been set up by experts here. First thing is to ask is whether or not it's magnetic. And if it is magnetic, then you can go on for, is it heavy for its size? Does the inside look metallic? And they say, if it doesn't, then it's a meteor wrong. If it's not heavy for its size, it's meteor wrong. If it has holes or bubbles inside, again, meteor wrong. But if it doesn't have holes or bubbles inside, maybe you should check for those thumb-shaped indents. They're known as, here we go, regmeglyphs. So a lot of meteor wrongs. If the meteorite is not magnetic, so it's one of those rocks, those achondrites or chondrites, then you have to think about, is it heavy for its size? If it's yes, it's probably a meteor wrong. If it's not, then you want to look for the outside to see whether it has that fusion crust. And if it does it look lighter on the inside? Then maybe it's a meteorite. And so that's the sort of flow chart that one would do. Our story begins really with Bob Allia, who taught science in Rockport Middle School for many years. He's recently retired and has developed quite a nature photography capability of late. And I encourage you to check out his Facebook page, where you'll see beautiful pictures of birds in particular. Anyway, one summer day, I think it was in 2018, he found an unusually dark rock on the side of a road in Dennis on Cape Cod. So here's a map of Cape Cod, and I believe Dennis is right around here, and this is where he found it. And he lent it to me in 2018 so I could work with physics students that I had back then to figure out what it was. So this is what the students reported on. They gave a PowerPoint presentation, and I basically just stole it. So they called it Identifying the Rock. And here's a picture of the rock. It has a bit of a luster. I could see why Bob wondered what it was, because it was probably a lot darker and more lustrous than the surroundings on the side of a street. There was a little bit of rust, but not much. And notice also there's a little bit of little light colored stuff, and that which could be quartz. I think there's some quartz there as well. So they looked at the rock. They also determined the density, and you do that by determining the mass and the volume. Mass found using a balance scale, and the volume was found using the displacement method, where you put get a beaker big enough to hold the rock, and you fill it up with water, a known amount, and then you put the rock in, and then they basically caught the overspill with another graduated cylinder, and they found the displaced volume of the rock. And the density ended up being 3¼ grams per cubic centimeter, which is not that unusual. It's a little bit denser than granite, but certainly not as dense as iron, which is in the 5s and 7s. They then did a hardness test, and you use basically the Mohs scale of hardness, where you have samples of the various minerals that have particular hardnesses, starting with talc being the softest and diamond being the hardest. We did not have diamond available to us, but we did have corundum, a hunk of corundum. And what you do is you scratch one with the other. And basically what they found is that the Allia Rock scratched talc, gypsum, calcite, fluorite, apatite, feldspar, which is a major component of granite, as is quartz. And then it became indecisive between topaz and corundum, that where, what was scratching what. That's how hard it was. And that remains perhaps the most unique aspect of this rock. And then one of the students, named Will, he had an incredibly strong magnet. I think he got it online. I'm glad nobody was wearing any pacemakers, but he brought that magnet to school to see if the rock was magnetic. And it wasn't. It was amazing how unmagnetic it was. And that's another important clue to what the rock is, considering that magnetism is an important way to figure out whether or not you have an iron or a stony iron. Electrical conductivity, I think what they did was they took a battery and they put one end on one side of the rock and another on the other side of the rock, and then they put in parallel the one of those meters, multimeters, and they measured a fair bit of voltage, considering that they started out with 2.9 volts and they measured 2.8 volts going across the rock. So they inferred that it had a lot of conductivity. So they concluded that maybe it was slag, but it was ruled out because it had greater density and lower hardness. Oh, that's interesting. It must have been a particular type of slag. I'll get to that later. Whether it was a meteorite, that was ruled out because there was those little pieces of quartz in the rock, and that's something that meteors never have, though it's not in the meteorites never have. That's not in the flow chart. And metallic ore, because it was not magnetic, and it was not as hard. I mean, it was harder than typical metals. Of course, there are other metals that are not magnetic, such as aluminum, for example, and tungsten sometimes. So they inferred that it was something called carbonado, because the density and the hardness, color, and composition came close to this black diamond, which they talked about. So basically, they inferred that this is a terrestrial rock made up of several types of minerals. Okay, that was the end of their report. Good report. But this was bugging both Bob and me, continued to bug us, nag at us. And so I brought the rock to the Harvard Museum of Natural History, and especially to their mineralogical section. If you've ever been there, they have one fabulous mineral collection. And they were very impressed with it, but they did not want to cut into it. They didn't want to take that risk. And then I brought it to a jeweler locally who said, oh yeah, I'll find somebody to cut into it. But then he realized just how hard it was, and he kind of backtracked and said, no, I don't think I'm going to be able to find someone with a hard enough slicer and a hard enough saw. So the rock ended up back at the school. But then over the summer, I think it was 2 years ago, I went to Mount Desert Island, Acadia National Park area, and discovered that there is this Maine Granite Industry Museum, and I paid a visit, and there was Steve Haynes, who said that he'd be willing to check out the rock and cut into it. So I ended up mailing the rock to him later on, and here are the pieces that were cut into. And one thing you can tell is that the inside looks like the outside in terms of color. And there are a few bubbles based on the small slice that he cut. The polishing did not yield a super glossy finish, so it's probably not glassy or metallic slag. And in case you're wondering what slag looks like, some of it shows a lot of flow features here, and that's the glacier slag. And there's all different kinds of slag. There's calcium. Well, I'll talk about that later, but slag refers to a smelting process, an industrial smelting process, where you're trying to refine some kind of metal, typically from its ore. And these are all examples of slag. So a few years later, I worked with my citizen science students at Rockport High School to revisit the Allia Rock. And so we did the density experiment again, came very close to what they had, 3.39 grams per cubic centimeter. And so that's higher than that for granite, lower than for Earth overall, an average of Earth's mass and volume, and certainly lower than for iron alone. So that kind of rules out most metals, especially nickel and iron. The magnetism, as I said, was minimal. The luster was smooth, but not that shiny. The rust was minimal. The hardness, we confirmed that it was between 8 and 9. And I think that's, I should say, yeah, that's corundum. That's right. And the conductivity, which we tried, seemed to be not very much. So there was a difference there in the measurements. So I would rule out iron nickel meteorite, especially because the magnetism is so little. And so I'm kind of siding with the idea of a carbide slag that resulted from smelting. And there's different kinds of carbide slags. I'm not talking about calcium carbide, or certainly not an iron carbide, but maybe a carborundum, which is a silicon carbide, and otherwise known as carborundum. So here we have our flow chart again. It's most likely not an extraterrestrial meteorite. Here you have, does it attract a magnet? No. Is it heavier than other rocks? I think of that in terms of densities. It's a little bit heavier than other rocks, so it's probably not a meteorite. Let's say I said no. Excuse me. Then does it have a dark thin crust on the outside? No. Did someone see it fall? No. Does it have those regmaglyphs? No. Basically, I'm missing some arrows here. Yeah, this should be a no. Did someone see it fall? No, it's not a meteorite. Also, is the inside lighter colored than the outside? No. So basically, I think that's what we're dealing with. And you can find, if you Google meteorite identification, you'll find these sorts of flow charts. How to identify a rock? You start and then you conclude it's slag. So that's basically all I have to say about this. I'll stop sharing the screen, and maybe you guys have.
Bill, before you get off that screen,
Yeah.
on the bottom of that slide, where it says, did someone see it fall? And you have yes, pointing to it's not a meteorite. If you actually see a meteorite hit the ground, doesn't that confirm it's a meteorite?
Yes. So I believe that this is an error.
Okay. It
There
didn't
should
look
be
right.
No. But I can't. I can't guarantee that. Here we go. Stop sharing. All right. So yeah, that's definitely true. The people in Chelyabinsk definitely saw something fall, and they were able to recover pieces of that meteoroid that became a bolide that then hit Earth and caused a lot of injuries.
Yeah. They pulled a big chunk out of a lake.
It did?
Yeah. Yeah.
Wow.
Big piece. And I don't know if you saw that on Mars, one of the rovers actually recorded an audio of something hitting Mars that left a 400-foot crater 70 feet deep. It made a 4-point-something earthquake. And it was very impressive.
That was recent. The InSight lander with its seismograph.
Incredible.
Yeah, and then the orbiter saw the impact crater.
Absolutely astonishing.
Bill, if we could get back to your test for just a second. You got two different results for the conductivity, is that right?
Yes.
So what do you attribute that?
Method.
Well, no, specifically.
I'm just
wondering
thinking
if
about
the
what the
outside
students
was
had
measured
available
one
to
time.
them.
I was wondering if they measured the cut part versus the exterior in the earlier test or something gross like that.
Oh, that's a good question. I think they were using the bigger part of the meteorite both times, and put their probes or their anode and their cathode from the battery on opposite ends. I think they both did that, but maybe they didn't work the multimeter properly in the second case. I did not supervise it closely enough.
Try to get a resistance reading on ohms to see if you got continuity through it.
Yeah, that wasn't done.
That's
We stuck with, I'm sure they stuck with voltage.
okay. Sometimes you can't push voltage.
Yeah. So
yeah, normally you'd measure the current after you put a voltage to it, and then you get the resistance in ohms, right? So
yeah,
yes, you could do that. So that was an incomplete thing to do.
If you measure the voltage across a portion of the meteorite, the voltage is proportional to the resistance. So in other words, if you get a high voltage reading, that means it's a very resistive rock and you have very little conductivity.
Okay,
I'd have to see your circuit set up to
Right.
be able to fully analyze that, but it sounds like you may have it reversed.
right, okay. And the current reading would have been the thing to do. As
That's right.
Bill
Yep.
said, yeah. And of course,
And that's
another
the-
way is to take those little pieces and do some chemistry with them, grind them up and subject them to different kinds of acids. For example, if it's a calcium based rock, then you should be able to get a reaction with strong hydrochloric acid, for example, things like that. But that's beyond my ken. I don't have a chemistry background, and the only chemistry I do is kitchen chemistry. And
Is
that's all
that
cooking?
a metamorphic rock?
What is?
The rock, is it metamorphic?
Oh.
It's-
I have no idea. I mean, it could be industrial.
yeah, that's another thing. I was thinking it could be industrial man-made, something man-made.
Mhm.
So what was it doing on Cape Cod, Bill?
I don't know. It was
A
Maybe
remnant
looking for
of
a
the
job.
historical heavy-duty smelting operations that they always had there?
I don't think Dennis is the sort of place that does that kind of thing.
I didn't think it was either.
It's
So
a
what's it
tourist
doing
town.
lying by the side of the road on Cape Cod?
Yeah.
Yeah,
So,
Michael, you can, on Cape Cod, it's a moraine of the ice ages. Consequently, basically, you can find rocks there from any place that originated in Ontario or Quebec, as far
Hmm.
north as, close to the Arctic Circle and anything in between. You can find some very strange samples there.
Wow.
yeah.
Right, but probably not carbide slag.
Probably not slag, I agree.
Unless we've had a recent ice age that we
Yeah.
haven't noticed.
Maybe it's
So-
anticipatory of when the North Atlantic conveyor shuts down.
Exactly. So I've had to give that rock back. Bob was clamoring to have it before he retired. And so you can go bother him on his Facebook page.
You didn't mind that you cut it?
He did not mind that I cut it.
Good thing.
I think I did ask him. And it was only an end piece. So it must have been a very good blade. Must have been a diamond blade.
Probably a couple.
Yeah. So if there are any folks who actually have meteorite collections, I'd be very interested. I would love to get one, but they're not cheap. Especially, meteorites that are about that big. So look, my finger, hold on, there we go. About that big, ones that you can actually look at. You're dealing with hundreds of dollars per meteorite, just for that size.
Yeah, being a meteorite hunter is very lucrative.
Yes. And the interweb is full of those sorts of people whose credentials are not certified. I don't think there's any certification process for them. So buyer beware, caveat emptor.
Probably about as trustworthy as autographed baseballs.
Though I'd be able to tell those two apart.
Baseball and meteorite? Yeah. I hope.
Yeah.
Especially if you cut the baseball.
Yes. The inside does not look like the outside.
There's a golf ball in here.
So maybe that's the next presentation, meteorite or baseball.
Yeah, well. Well, that was excellent.
Yeah. Well, thank you guys.
Thank you for
Gals.
the entertainment.
Yeah. And I don't know what's going to happen for November. If you have any ideas, just let me know. It should be space science for November. Either
Excellent.
that or turkey.
Hey, Bill,
Yes, Paul.
Yeah, somebody put up on chat that they went to school in Somerville. I grew up in Somerville. I was just wondering who it was, but.
Oh, I haven't looked at the chats. Hold on.
Yeah. Thought it said that.
Okay.
Well, they must
Oh,
know who they are.
Steve Haynes and Dwight says this. Steve Haynes and I went to Somesville Elementary School, not
Oh.
Somerville.
Where?
There were 6 in our class. He lived up the road about a half mile from my house. Yeah, he gave an Earth and Space report. I do believe that he's certainly a hoot, and he gave a very spirited talk about all the different granites in Maine.
Steve is just completely amazing on his depth of knowledge of granite. And he gave a talk to the Boston AIA architects group on granite buildings in in the Northeast, because a lot of the granite came from Maine, like for some of the buildings in Boston and Washington, D.C. and New York and whatever. But he was kind of hardcore in high school, got involved in drugs, but he straightened himself out. And I'm just phenomenally amazed with his depth of knowledge.
Yeah, I was very impressed, having visited the museum with his partner. whose
Juanita.
name-
Juanita.
Juanita, yeah. And he serves all sorts of school groups on a
Yep.
regular basis, so that's really cool. So somebody asked for November subject, Hubble versus Webb picks. Okay, well, getting people who know about Webb, they're hard to
I just
find
gave a
right now.
talk on that 2 nights ago to the Mass Med.
Oh, you did, Mario?
Yeah, I think Mike has me scheduled for March, right? Mike, you there?
Yeah, I'm right here.
Yeah,
I
so
believe
what
so.
I
I'm
did
not
is-
positive about the month, but yeah, whatever we talked about.
Yeah, well, you pick the month. It doesn't matter
Yeah,
to me.
no, I wrote it
It's all
down. I
done.
just don't have it right here.
But what I did is I compared I showed how it was built, and then I compared web pictures with Hubble pictures, and then for ground-based, I used my own pictures. So I had 3 pictures of the same object, and I got an interesting response.
That's good. Yeah, I think the real gold is going to be when they combine those data, the data from both telescopes along with Chandra and even older stuff like Spitzer Space Telescope. So
Yeah, one of the
that's a
photos
good
I
idea, David
found
Tower.
combined ultraviolet, visible from Hubble, James Webb, and
Infrared.
ground-based radio.
Oh,
to
yes,
Show the
radio.
complete spectrum of not Cassiopeia. Let me see. Why am I blocking on the name?
But the pillars,
Centaurus A.
Centaurus A. Oh, yeah, that's always a good one. Active
Yeah.
galaxy spewing its guts. Well, on that note, I guess I'll retire and wish you well. Thank you for participating, and catch you in November.
have a
So
great
long.
night, Bill. Thank you very much. It's excellent.
Shirley.